So, lesson 3, we're finding the area of polygons by composing and decomposing into familiar shapes. So what that means is we're going to take some unfamiliar shapes and split them or break them into shapes that we already know how to work with, such as rectangles and triangles. So in example 1 here, it says, what's the area of the isosceles trapezoid shown below? So similar to an isosceles triangle, an isosceles trapezoid, 2 of the sides are congruent, which means they have the same length. And in this case, that would be this side right here and this side right here. Now we can also identify within this trapezoid a shape that we're familiar with, this triangle right here, and we're going to call that triangle 1. Now similarly, if we split, or we just draw a little dashed line right here, we can split the other side of that trapezoid into 2 familiar shapes. Another triangle, we'll call that triangle 2. And then a rectangle in the middle, and we'll call this rectangle 3. So what we'll do now is try to figure out some missing lengths. So if we look at the top part, the top base here of this trapezoid, made up of the base of that triangle, that rectangle, and the base of that triangle, we want to start to identify those lengths. Now we know that the length of this base down here for this rectangle is 6 centimeters. So similarly, up top, it must also be 6 centimeters. Now we know that the length of the entire base is 8 centimeters. So if we subtract this 6 centimeters, we're left with 2 centimeters, which needs to be split between those 2 triangles. So the base of this triangle must be 1 centimeter, and the base of that triangle on the right must also be 1 centimeter. And we can quickly check that by adding 1 centimeter plus 6 centimeters plus 1 centimeter is 8 centimeters. So now what we can start to do is find the area of those triangles and the rectangle. So the area of triangle 1 can be found by multiplying 1/2 times the base times the height, or we could do the base times height divided by 2. So if we do 1/2 times the base times the height, I'm going to do 1/2 times the length of the base, which is 1 centimeter, times the height, 4 centimeters. Now we could also commute those, so we do 1/2 times 4 times 1. And the reason I do that is because half of 4 is 2, times 1 is still 2. So the area of triangle 1 is 2 centimeters squared. Now the good news is, we know that triangle 1 and triangle 2 have the same dimensions, because we know this side right here is the same length as this side. We know that the bases are each 1 centimeter, and we also know that the heights are 4 centimeters, which means that triangle 2 has the same area as triangle 1. So finally, we have to find the area of rectangle 3. And we could do that by multiplying the base times the height, which is 6 centimeters, times 4 centimeters, which gives us 24 square centimeters. So we do have one thing left to do. In order to state the area of that trapezoid, we need to find the sum of those 3 areas. So we're going to write the area of the trapezoid equals, and we need to show the addition here of those 3 areas. 2 plus the area of triangle 2 is also 2 square centimeters, plus the area of rectangle 3, which was 24, which gives us a final total area of that trapezoid being 28 centimeters squared.
Example 2, what is the area of the kite shown below? we're going to go ahead and break apart or decompose this kite so that we can find its area. I do see several shapes within this kite, and one way I see I can break this apart is by drawing a line of symmetry along the kite to make two symmetrical triangles. I'm going to go ahead and find the area now by writing the area of a triangle. And once I find the area of one of the triangles, I can simply double that area and I will have found the area of the kite. So we do know from lesson 2 that we can find the area of a triangle by multiplying its base times its height and dividing that by 2. So let's go ahead and identify our base and height of the triangles we see. So basically, the base of this triangle is shown as I draw this purple line, and so I see the base is formed by this 42 centimeters and this 20 centimeters. So I need to add those two numbers first to see what the length of the base is, and I can see that the base is 62 centimeters. The height, I can see where that right angle is formed with the base, is 18 centimeters. Okay, so I'm going to go ahead and take those two dimensions and plug them right into my formula to figure out what the area is. So area equals 62 times 18, which I'm then going to divide by 2. When I go ahead and multiply 62 times 18, I get 1,116 centimeters divided by 2, which actually equals 558 centimeters squared. And so I can see that if the top triangle's area is 558 centimeters, then the bottom triangle, the one below, is also the same area. So I'm going to go ahead and times that amount by 2. And we can clearly see that we get 1,116 centimeters squared for the area of the kite.